So we will be soon starting to build the snake game. That's why we want to record it in case someone misses the beginning, for example. Oh, we're already 16, wow. Nice. So if somebody missed the Firebase parts, we have recorded it and we will upload it in the evening. So first part of the day, we have done an exercise where we added a win condition to our memory game. And then the second half of the first session, we created a Cloud Firestore database, and we learned how to read from it and how to write to it, how to save the score. And I added a couple of rows at the end that I'm gonna show you. So we added a use effect that runs every time win runs. There is echo. Yes, still echo. And so when win becomes true, we are saving the score, and then we print to the console when the score has been saved. Score saved. After that, we fetch the leaderboard, and then we print the leaderboard to the console. That is something that I have added the very last second after I said that it's now a lunch break. These two lines. So the result of this is that we first save the score, and then we show the new leaderboard with the saved score in the console. These lines are on my GitHub in the last commit. Alrighty, let's move on to the section called Snake Part 1. That's what we're going to be going through. So how do we build a snake game? The first part every time is to make sure we want to know exactly, make sure we know exactly what should happen, how the game is played, what the rules of the game are. And it seems like all of you guys have played Snake. So we're not going to go too deep into the details. So we are again going to build a grid of a specific size. I'm going to use width 20 and height 12. So it's going to be rectangular like that. And on the grid, we're going to have a snake from the start. I already have like a baby snake. It has a head and a tail, and tail is just 1 cell long. So in total, the snake is 2 cells long. Here, do you see my screen? Is an example of what a snake could look like. This is not the initial state because the tail is 2 cells long. But we want to start with just head and 1 cell of the tail. So we can say that when the game starts, our snake will be in the middle of the grid, and it will be facing to the right. This snake is facing to the left. This is just an example of how the game could look after it has eaten 1 food piece. What do snakes eat, like mice or something? I have a huge fly that really likes me. Anyway, I don't like you. Right, so what we see on the grid is the snake, and also we see a food item. Maybe it's a red apple. And the food, it should spawn, it should appear at a random location. So what I want to build is, I have a snake in the middle. It has total length 2, head plus tail. And there is randomly positioned a piece of food on the grid. So when I say that I start the game, then the food maybe is here. Then I just refresh the page, or I restart the game. The food should appear at a different position. So every time I start the game, it's a new position. Randomness is going to be one of the puzzle pieces here. Just like in memory game, we have random cards. The card collection that we have is different every time. It's shuffled every time. Here we have the food that is gonna have a random position every time. Yes, and of course there is this little game detail that the snake moves on the board. You cannot stop it, right? It always moves with some frequency, with some speed. We can only tell it go up, down, left, or right. And we're going to be using our keyboard keys for this, the arrow keys. Or for those who are experienced computer games players, what keys do we use to move our characters? With our left hand. Maybe it's like very much in your, backbone. We use WASD. So W is up and S is down. A and D are left and right. So often in the games where you like point and shoot, you run with your left hand and then you shoot with the mouse. So you can either move the snake with the keys up and down on the keyboard or with the keys WASD on the keyboard. I also have some optional sections in this game where we, actually in all of the games, where we fit the games to use on our mobile devices. So for the snake game, you need to also render some kind of component with buttons, up, down, left, and right, because if you tell the game to listen to the keyboard keys, that's not gonna work on a phone. You need some physical buttons rendered on the page in order to play it on the phone. Yes, and if the snake goes into a wall or if it goes into itself in its own tail, then it dies. And whenever the snake eats the food, its tail gets longer. So these are the two game logic points we need to implement. Also, of course, we need to figure out where the snake should be in the next frame. So let's say that we start with some frame. This is how everything looks. And then half a second goes. We need to calculate the new frame, where the snake should be this time, so that it moves by itself every time. So it will look at what is my direction. And then we calculate where to move the snake on the grid, how it should look, what its new position should be. So that's also something we will be doing. But let us first, as we did with memory, render this grid. We're not gonna start with implementing any logic in the state. We just want this picture to be shown. Maybe we just start actually with only the grid itself, without the snake, without the foot. We just want our cells to look nice. So we got some feedback about CSS. So when I was building memory game, I explained to you guys in quite some detail what I was doing in the CSS file. And I wonder if I maybe should just paste my CSS code and be done with it, so that we focus on the game logic. All right, so so is it okay with you that I don't go through the CSS? Yeah, so we'll focus on the logic, on the JavaScript. So let's get on with it. What we are going to be coding is, let's close all the files that are open. Maybe need to save some work. Then create a git commit. The instructions are somewhere at the end of memory part 1 and memory part 2. If you need help, write in the chat for them. So components, we're closing the memory folder. We are opening the snake index.js file. Right now, this file just says snake game will be here, and we have a text container. Let's just check what we had in memory, in the memory game. What do we render at the very bottom? We have a div with class name game container. Do you remember what game container does? Why do we have this div? What does this styling really do? Yeah, it centers the content of the game on the page. We say that we want it to take 40% of our width, and it should be centered. How about we continue the same way? So all of our games will be centered the same way within the same container. So then we can actually reuse this game container and have it here. So instead of text container, have game container, and we'll fix the CSS later so it's available in both games. We will move it up to the app.css. We remove the H2, and we are gonna create a grid again. Remember, we had memory grid. Now we're gonna create snake grid. So div class name snake grid. And in the CSS, we will say that this grid should be 20 times 12. And the CSS will fix it so that we will be able to just push to have, so 20 times 12 divs in here. So we just add 240, I guess, elements in here, and they will all be positioned nicely in a grid. That's the CSS job. So how do we render 240 things? Let's first define that we have width and height. So width will be 20, height will be, const height will be 12. Now, let us create those cells. So what we want to add here is lots of divs, right? And every div we will call snake cell. So I'm going to do this here in the beginning. Just like we did in memory, we're just creating an empty array, cells. And so const cells equals empty array. And then using a for loop, let I go from 0 to I is less than width times height, I plus plus. We're just gonna generate our cells. So we take the cells array and we push those divs. Okay. And every div will be a snake cell. So class name, snake cell. Remember we did like this first when we started building memory game? Just created a grid and then we created an empty array for cards, pushed some cards, and then we inserted them here. So inside this div, snake grid div, we open curly braces and we type what for this all to work? I'm asking you because we've done this before. I want all of my cells that I have just created to be rendered inside the snake grid div. So
cells?
Exactly. So here, this array contains all of these cells. Also, there is one thing missing. Remember, I told you that when we create a lot of the same element and we're adding all of that to a parent, we need to give a key to the element. So key, let's just have pi within curly braces for now, so that React doesn't complain. And then we take this array with cells and put it inside snake grid div. Done. This is our first little draft. We have just created an empty grid. Now we're gonna add a CSS file. It's gonna contain snake grid and snake cell. Game container will have to come from somewhere else. Let's start with snake grid and snake cells. So next to index.js in the snake folder, create a file, index.css. And we add so in the guide, I have it slightly different than what I want to have now, is because in the guide, I have solved the problem of different screens already. I'm already solving the problem where on the mobile screen, I actually wanted to take the whole space. So we're not going to have this yet, because then we need to have it in other places too. So copy snake grid and snake cell from the second part of this CSS. And then add height 24 VW to snake grid. Like that. There. Now we want to import this CSS file that we've just created. Otherwise, index.js has no idea where these CSS classes come from. So we write import / index CSS, index.css. And now about the game container. Let's go and find where the CSS class is defined. I think it is in index CSS in memory folder. Go to memory folder, take game container CSS class, cut it out from here, Control X, save, and put it into app.css underneath the text container. So app.css now contains text container and game container CSS classes. And since app.js is the root component, its CSS is available to all the children. So it's available both to memory and to Snake and to home and the Minesweeper components. Okay, let's run this. Yes. I have an empty grid in front of me. Do you have it too? Are you following along? Thank you. We continue. Now we have rendered all of these cells the same. They're all same looking. But there are some cells on our grid that should have a different look. We're gonna have three other kinds of cells. It's the head, it's the tail. So all the tail cells are gonna have the same color, but the head is gonna be marked as a darker one. I'm going very simple, so let's see. This is black, this is gray. So the head is black, the tail is gray, the food is red. This is my extra CSS. I'm gonna take this snippet from here, from the guide. Head, tail, and food. And I'm giving those black, gray, and red colors. Please change them to whatever color you want. Maybe your food is green, it's a green apple. Do whatever you want with those colors. I think it's going to be obvious to the user what the snake is and what the food is, whatever colors they are. So I'm taking those three and I'm adding them to index CSS in the snake folder. By the way, forgot to say, oh no, Jocelyn left, that our schedule for the rest of the day is we go 50 minutes and then we take a 10 minutes break. 50 minutes and 10 minutes break. 50 minutes, 10 minutes break, and then we have the Access Q&A. So I'll try to keep the schedule very easy. Could you please write that in the chat as well, in case people didn't hear what I said? I just said that our schedule for today is we go till 1:50, 10 minutes break, 2:50, 10 minutes break, 3:50, 10 minutes break. All right, so I have added head, tail, and food to my CSS so that now I can add a CSS class to this div, and it will be rendered red, black, or gray. So I'm gonna test it and I'm gonna say food like that. And I'm expecting my whole grid to become red. I have a lot of apples on my grid and no snakes. There. Okay. Now, let's talk about game state. We want to represent the state of the game in some way. And we are going to change this state every half a second, because our snake will be moving every half a second. Except for those half a second movements, we'll have other game state changes. And that's when somebody presses a button. So our snake, it should know where its head is, what cell, where its tail is. And a tail is a list of cells. It can be long, right? And also, the snake should know which direction it is moving in. So this snake here is moving in the left direction. So that's left, or you could say west. But this is what it looks like. Actually, it could be so that I have just rendered the snake and now I have pressed the up button. Then this is what it's gonna look like until the next frame refresh. This is when the snake is gonna start moving to, I was saying this, and this, and pointing on my other screen, I'm sorry. So say that this is what the snake looks like, but I don't know whether it's actually gonna move left or right, from left or up or down from this picture. Because maybe I have rendered it like this, and then right after that render, I pressed the up button. But the snake is gonna move after my refresh. This is where I'm gonna see the result. So it actually could have direction up if I press the button. So pressing buttons changes the snake's direction, simply put. And here is what I propose we could describe our game state like. So our game state should consist of two parts. One is called snake, and the other is food. Snake is an object which consists of three things: head, tail, and direction. So deer is just a short for direction. Then we go deeper. The head of the snake, it's a point on this grid. And we will describe points like simple objects like that have an X coordinate and a Y coordinate. On the grid, we decide that this cell, the upper left cell, has coordinates 0, 0. X equals 0, y equals 0. And then X will increase to the right, Y will increase downwards. This is how I think all games are rendered. You have 0, 0 in the top left corner. It's quite different from drawing graphs in mathematics, right? You have then normally origo in the center and x goes to the right, y goes upwards. In the rendering, we have y goes downwards. And that's because this is what the logical flow of elements are. It's like the reading order from left to right. You start at the top left of the page, and then you go to the right, and then you switch row downwards. So think of it as like a page with rows of text. This is why we represent it like that. We start top left. So this position here of the food has coordinates 2, 3. Do you agree? We start with 0. So we go 0, 1, 2, 0, 1, 2, 3. This is the food element in our game. I call this object game. Just like in the memory, we had game consisted of cards, first card, second card. Here we have game consists of snake and food. And snake has a head. It also has a tail. And it's quite nice if we order these tail cells. So this is an array, right? It has braces like that. It's an array of objects, just like cards was an array of objects. And here we have 2 tail cells. So let's compare them. Head is x9, y5, this cell. And then the other cells have y5 as well. They're on the same vertically. And x is 10 and then 11. So my tail array, the first element of it is the cell just after the head. And the last element is the last tail cell. This is my data model, so to say. Also, the snake has a direction. And here we could have different implementations. Maybe we could say, yeah, north, east, south, and west. We're gonna say top, up, down, left, and right. You could also use numbers for this, like 0, 1, 2, 3. And when using numbers, some operations can be much easier. For example, you can easily compute that 2 directions are opposite. If you have numbers 0, 1, 2, 3 that go like the clock. 0 is 12 o'clock, then you have 1, 2, 3. So 1 is clockwise. Maybe I'm showing it to you mirrored. Then, in order to see if 2 directions are opposite, you can subtract them, and it should be 2. 0, 2, 1, 3 are opposite. But when you have words left and right, up and down, then you need to do a little bit more work in order to fix that. So if you want, you can change this to 0, 1, 2, 3. It might make your implementation then easier, but I'm gonna be verbose like this: up, down, left, and right. Okay? It's up to you. If you feel like you can handle it with numbers, do it. So this is what I want my state of the game to be like. How do I implement it then? Well, let us create the state the way we know. This is what we're used to. This is what we learn from memory. We use the use state hook. In order to do it, we need to import it from the React library. So we say import React, comma, brace, curly braces, use state. And then at the top of our component, this is where we want to place all the state variables and then all the effects. And then at the bottom, we want to place the rendering. Everything between the effects and the rendering are our helper functions and things to compute before the actual return statement. So I'm going to create const game set game equals use state. And here we want to send a method or send a call to a function generate game, right? Just like we did before with generate cards. Now I think we can just generate the whole initial state. It will give us an object looking like this, but let's decide that snake will always start in the middle looking to the right. It will have a short tail, just one. But food, that we should randomize. We should choose a random location for it. So I am going to, I think, create a new file while I extract all of my helper functions. Because remember how it happened with memory? We ended up with a lot of code in between here and there, so that the structure of the whole component became maybe a bit blurry for some of you. It is quite blurry for me too when I have so much code. So I want to extract all the helper functions that we did and put them in a separate file. I will do that in the evening and I will push it to my repository. And now when we code the snake game, we will try to keep it clean and all the extra functionality, let's extract to an extra file. So I'm gonna create, this is not in the guide, by the way. So this is a little change we're making. But all the code snippets are gonna look the same. So I'm creating a new file called helpers, maybe, .js, little h, because this is not a component. This is a library of functions, we can say. And to make this work right away, I am going to import it here. Import. Now I don't write just the file name. I want to import all the functions from this file. So I write start, and then I'm also going to write as helpers. So helpers is my variable. And whenever I want to call some function from the file, I will write helpers.generate game, for example, from ./helpers.js. So I'm going to go to helpers and I am going to create a function that generates the initial state of the game. So it creates a game object. I'm going to create this function generate game. And I'm going to put the word export in front of it so that our index.js can use it. Export function generate game. Does it need any parameters? Nope, because it can do everything itself. I mean, we don't need to tell it really Ooh, or maybe we do. I am thinking about the width and height. I have defined them up here, but my helper function here, it actually will need, I think, the width and the height. So either I think in order to my functions to look the same as in the guide, I'm just gonna, for the simplicity of it, copy these two values, width and height, to helpers.js, so that you don't get confused when I add some extra parameters to my functions. But this is not really a great way to do it. It's better with parameters, so that index.js tells the helper function, generate game of this size. Okay? But since my guide is not updated for this, so that you can paste the snippets easily, I'm gonna keep it like this. I can change it later. You can change it later if you like. So, generate game. You know, we could already just start writing return and our object. And then we'll see if we need to make it more complicated than that. So what we need to return is a snake. It will be an object. And then comma food will also be an object. What the snake has is head. It's an object. It has X and Y attributes. It also has a tail. And that's not an object. What is it? An array, right? So brackets like that. All right. Head has X and Y. Where is it? And they are just plain values. So I want to place my snake in the middle of the grid. So I'm gonna take both X and Y will be the middle of width and height. My width and height are right now even numbers, so I can just easily divide them by 2. And I'm gonna do like that for simplicity. I am assuming width and height are even numbers. So my X is width divided by 2, comma. My Y is height divided by 2. Now, what is the tail? Oh, right, the snake, it has 3 things: head, tail, and what? Do you remember? Apart from the head and the tail, what does the snake need to know? Where it is going, right? So the direction. So deer. And I am gonna start with right. It will always point to the right. Now, the tail, it will only consist of 1 element. So I'm adding 1 object here. This object inside the tail array. This object will have also X and Y. So X, if I imagine that I have my head, the head of the snake in the middle, and the snake is pointing to the right, then the tail should be just 1 step to the left from the head. it should have the same y, but x should be closer to 0, right? So if x is width divided by 2 for the head, the tail should be width divided by 2 minus 1. And y should be the same. Height divided by 2, as for the head. So head should be 10, 6. So width is 20, height is 12. 10 and 6. Tail will have one cell with 9 and 6. So the snake part is finished. We have created that. Now to the food. It should also have X and Y. And we said that they should be random. And now let's think about this, about the food object. Every time the snake eats the food, it will actually appear again at a random location, over and over and over, right? And when we generate this location for the food, we need to make sure that this new location is not one of the cells that are already taken by the snake, right? We cannot generate our food that is already in the snake's mouth. That's not fun. Our food is scared of the snake. Doesn't want to be on it or inside it already from the start. So I am feeling like it would be nice to create another helper function that would generate the position of the food for me, depending on where the snake is. So it will give me new position of the food, and it will guarantee that it is not one of the cells taken by the snake. So for that purpose, I'm going to create a new function, and I call it export function generate food. And I said that I want this function to guarantee that it's that the food is not anywhere on the snake. So this function needs a parameter. It needs to know where the snake is so that it can exclude those cells. That's why we're going to send a snake here as a parameter. So now that we have said that, oh, we can have a generate food function here, we can actually call this function in order to generate food in the first place. So we will call generate food, and then we will send the snake to it. Now it gets a bit tricky. Here is the snake. We can't just say snake here. We haven't, this would refer to a variable called snake, and we don't have it defined. So this is what I'm going to do now. I'm going to extract this code for the snake into a variable snake. So I'm going to say const snake equals all of this, the object next to the snake key in my return object, like that. And then we can return snake colon snake, so it uses that variable. And food is generate food with snake as a parameter. So I'm referring to this variable now again. Maybe it's confusing that the variable snake has the same name as the key to the object, but hope we can get wrap your head around that. So generate food function we'll implement after the break. Now we have break until 2 o'clock. I'm not gonna show you a timer on my screen share because maybe I want to do something in the meantime. So see you at 2 o'clock. Now we are returning from the break. And we are gonna continue. We left off here in the helpers.js, and we have generated almost all of our game object, but we don't have this piece, generate food. So generate food, it will depend on the value of snake, because we shouldn't generate the food at any cell that snake takes up. So the logic of generate food is gonna be like this. We're gonna start off with generating some random position, and then we will check, is this position one of the snake's cells? And if it isn't, we're happy and we can return it. But otherwise, if it's not, we should generate it again. And then we check again, is this new position one of the snake's cells? And if it's not, we're happy, but it could be that we are so unlucky that we keep randomly generating positions that are one of the snake's cells. So does it sound like some programming concept to you that you know what we should use here? So if I rephrase it, as long as my generated position is wrong, I want to continue generating it. This is a while loop. While it's wrong, generate new position. So it will check all the time. Is this new position good? No. Okay. Generate again. Is it good? No. Generate again. Is it good? Yes. And then we exit the while loop. So we are going to start with some position. So we say let x equals something. I could say, for example, let x equals 0, let y equals 0. And then I want to write my while loop, right? While x and y are a position that one of the snake's cells take, I want to generate them again and again and again. Then it's handy to have this initial value of x and y as a bed value. It's easier like that. And the bed value is, for example, snake.head.x and snake.head.y. We know that these values are not acceptable. And now that we have initialized our x and y, we can do our while loop, and we know that we will enter it. So we go while, and now we need to compare x and y to snake head x and y. And it seems like we're gonna have to do it here and there and everywhere, comparing different points. So or cells. So I'm gonna create another helper function. I'll call it is equal, and I will send 2 cells into it. It will tell me if they're equal or not. So function, question is if we need to export it or not. Maybe it's only a function that needs to be in here. I think it only needs to be in here. I'm gonna write function without an export keyword, like a private function for this file, not public, but secret. So function is equal, and then we have 2 cells or points. Let's call them P1 and P2. So when do I know that P1 equals P2? Well, when P1's x equals P2's x and y equals y. I'm gonna write P1 dot x equals triplet equals P2 dot x and so double ampersand P1 dot y equals P2 dot y. And this is what I return. This is gonna be a Boolean value, true or false. Is equal P1, P2 will give me back true or false. So let me create a variable here that I'll call food. This is what I'm generating, right? And then I can just write x is x that I defined above, y is y, right? I can do like that. But it is, this, I think, is too much code. We can simplify it a lot by just copying the snake head object. So what I'm gonna do is, I'm gonna say let food equals ... snake head. So here is my x and y inside this object. I have copied snake.head. Then I can remove these 2. So now my food cell is just as the snake's cell. And I'm gonna say, as long as food is not snake's head, sorry, as long as food is snake's head or it is snake's tail, I wanna generate new food. So as long as is equal food and snake.head, then I want to generate new food, or 2 pipes like that, I think they're called. So this is AND, logical AND, and this is logical OR. 2 vertical lines. So if food cell is the same as snake cell, or the food cell is one of the tail cells, and tail cells is an array. So now we're gonna do some array magic again. So we're gonna take food, snake.tail dot. Remember, we looked at every function. We checked that every element in an array satisfies a specific condition. Now we're going to use another function similar to that, but it's called sum. There's every, and there is a sum like that. Not sum as in plus, sum. This returns true if there is at least one element satisfying the condition. So every returns true if every element satisfies the condition. Sum returns true if there's at least one. Sum, and then we have a cell. So we pass a function to sum, right? It takes each element in this tail and it checks a condition on it. The condition is equal food and cell. There, I'm done with my condition. As long as either the snake's head equals to food, or there is some tail cell that is equal to food. Then I want to generate new food. So now I'm gonna say food equals new object where x is a random number between 0 and what? Want you to wake up sometime so it's you're listening. So we want to generate a random position for the food, right? And we do that by generating x and y randomly. So our x should be a random number between 0 and what? Somebody said 20, I think. And 20 is correct. It is also the value of our width variable. And y should be a random number between 0 and what? 12, which is the value of our height variable. Yes. So making random numbers in JavaScript, it often involves that you need to first create a random number between 0 and 1. Remember I showed you that function. We have math.random. This is a random number. This is like a little library, or it's actually big, method random that we can use. Don't need to import anything. It's built in JavaScript. It returns a random number between 0 and 1. How do we make this a random number between 0 and 20? Then we can multiply this by 20. Then we'll get another, so go math.random times 20. This will give us a random number between 0 and 20. It will be at least 0, that's the lowest possible, and it will be at most almost 1, and that's almost 20. And then we want to make an integer out of it. We don't want any of those decimals. What we want to do is we want to remove all of the decimals. We don't want to round it up or down because we don't want the value 20 to be there. I just want to erase all the decimals, and that's the math.floor function. So since this is a little bit of a cumbersome operation, let us also extract it to a separate function. So we have is equal. Let us have function random And it will take as a parameter maximum value we want to have. So like 20 for width, 12 for height, and then we can use this function a couple times. And yeah, this maximum will be exclusive. So yeah, I'm gonna write max here as a parameter. It will return math.random times max, and then we want to floor it all. So in front of math random time max, we call math.floor. You know, there is one function called math floor. It has a brother or a sister. You know what that is? Is it the roof? Is it the sky? No. What is it? It's ceiling. So we have floor and ceiling. We are inside a house or apartment. Look down, there we see the floor, we look up, we see the ceiling. Okay, so return math.floor, math random times max. That's random, our random function. So now we can write things like, okay, I'm gonna generate this food and x will be a random number between 0 and width. And x and y will be a random number between 0 and height. And this while loop will roll and roll and roll while food is in a bad position, either head or tail. Maybe we'll have bad luck. We really need to have this while loop. It is totally possible that at least that we'll have some like 2-3 times in a row when we will generate bad cells. And then when we are here after the while loop, it means that this condition inside the while loop is no longer true. Now it's false. And we end up here at the end of the while loop, meaning that our food variable is now good. It's not one of the snake's cells. And we can return it, return food. Okay, now we have generate food, and we can even call this function later. Whenever our snake eats the food, we will want to update our state with a new food in a new position, random position. Okay, so I have my generate game complete. It uses generate food and some other small helper functions. Now I can use generate game in my component index.js. I'm going to that, and I am sending helpers dot generate game to the use state. This is my initial state. So let's now fix so that we can actually see those red, black, gray, or whatever colored cells on the grid. For that, we need to modify our class name for these divs so that if a cell is a head cell, we render it with CSS class head. If it's a tail cell, we render it with the CSS class tail. And if it is a food cell, we render it with the CSS class food. Otherwise, we render it as a normal cell. So we are gonna write some logic like that. And what is the cell? How we're gonna go through that? I propose that we use a double for loop so that we go through our cells row by row. Why a double for loop? One for loop will go through a row, another for loop will go through the cells in the row. So one will go through rows, another will go through columns, so to say. So I'm gonna rewrite this so that we have let y equals 0, y is less than height, y plus plus. Why do we go through y first? That's because y is the index for our rows. And that change between rows is slow. It's the outer change. The inner change is a change of our cells. So that's the for loop that's gonna run fast. Around it is the for loop that runs slow. If you've never seen a double for loop before, this is challenging. But if you have, then maybe you should recognize the thinking. So the inner for loop is let x go from 0, x less than width, x plus plus. And then cells push will be inside the inner for loop. So we have outer for loop for our rows, inner for loop for our cells within a row. And then inside this, we do cells push, and this is the snake cell. We are using key equal to I right now, but we have removed the I variable, so we need to fix it. Let us say that our key is x plus dash plus y. This is a string that will be unique for each cell. It's its coordinates. Okay. And now, inside this inner for loop, we can say that our cell, const cell, that we are looking at and that we are rendering right now, is an object of x and y. This object initialization is the same as writing x colon x, y colon y. So we just remove these things. It's quite fresh JavaScript, ECMAScript feature. So if we have two variables that whose names should be the keys of the object, we can write it simply like that. I'm gonna write a comment, same as x colon x, y colon y. This is our cell. And now let us produce this CSS class name that we're gonna use. It's either gonna be head, tail, food, or nothing. So let's, I'm doing it a little bit different from how I did it in the guide so that it's a bit more readable. The guide has just slightly different implementations. There are like 1 million different ways to write this code. So I'm gonna go and say const class name is empty at first. So this is the base case. But if, oh, and sorry, not const, I'm gonna say let, because we might change this. We might change class name to head, tail, or food. So I'm writing if helpers is equal. I'm using that function. I'm just gonna go and check if that function is exported. No, it isn't. I need it outside there. So export function is equal in the helpers.js. I go back to index.js. And I have if helpers is equal. What am I comparing? Cell and, for example, the head of the snake. Where is the head of the snake in this code? How do I find it? Where is it? Does anybody see it? It's hiding, but it's there. Do you see that it's hiding somewhere here on line 9? Yeah. So it's hiding inside the game object. Remember what our game object looks like? It's the snake and the food. So we can write then game.snake.head. So if helpers is equal, I'm using that helper function I wrote there, and I'm sending two cells that I want to compare. The X and Y cell from my for loop, and this is going to be every cell on the grid. So we go from 0, 0, 0, 1, 0, 2, 0, 3, until the end, all 240 cells. So first I'm comparing this cell to game snake head, and if they're equal, then class name here should be what? What different class names did we define? In our CSS, we said we'll have a red thing, a black, and a gray, and we called them something head, right? So class name shouldn't be head. And then we go and write else. And now comes this interesting part again. Oh, right, else if. We have 3 cases: head, tail, and food. So I am gonna write here, yeah, else if and else if, like that. So this second case will be for the food. It's not that hard. Class name, food. And this last one, it's a harder one. It's gonna be class name becomes tail. Do you know what I'm gonna do now to you? I'm not gonna break you into rooms, but you guys should now think a little bit. I'll give you 10 minutes and try to do this yourself. This condition here should say that cell is equal to the food cell. And this last condition here should say that there is some cell in the tail of the snake that equals to cell. So try doing it on your own. And in 10 minutes, I'm going to show you how to do it. So I didn't take any break before. I'm going to take a little break now. I've just pushed my code to my GitHub in case anybody needs them. All right, the break, or break for me, hard work for you, is finished. Let us now go through how to do this. How are you guys? Did you figure it out, or are you halfway? Okay, let's see. I think the second if statement should not be as hard. So what we want to say here is if cell is the food cell. So we're going to use helpers is equal again, but we're going to compare cell to the food cell. So we're saying helpers is equal and then cell. And then we try to remember or find where the food cell is. It's also hiding along with the snake in the game object. So we write game dot food. If you are not sure what the game object looks like, well, just go to helpers generate game and see what we do there. Here is generate game. This is what we return. Snake and food. So, first statement, if cell is equal to snake's head, then we say class name is head. Second, if cell is equal to the food cell, so game.food. And the last case is if there is any cell in the tail that equals to cell. And we have done this before in helpers. Remember, we did this in generate food. We said that while there is any tail cell that equals to this food that we're trying to generate, then we should continue generating random food position. So this is what we can steal. It says snake tail, this is an array, and then an array has a method, standard built-in method called sum. And then you send a function. Sum cell is equal to food. So I'm gonna write it again. Don't copy maybe. Let it try to sit, or I mean, do it with your fingers and it will absorb it through your fingers. So I'm gonna write helpers. Helpers. Both 19 and 21 lines should have that. So helpers, and then we first, oh, wait a second. I started in the wrong end. So first I need my array, right? And then I call sum function on the array. And my array, the tail, is inside the game object. So I go game dot, and then inside game there is snake and food. I'm interested in snake. And then inside snake there is tail. This is my array. And then on that array I call sum. Is there any cell in that array that is equal to this cell? So then I'm going to send a function, and here is a variable name that I should create in order to make it easier to read. I'm going to write not cell. I already have cell, I can't write that. I'm going to write tail cell. This is my variable. Every cell in a tail will be gone through, and we will check if helpers is equal. And what are we comparing now? We are comparing cell to tail cell. And there we have it, I think. So now we have a class name that's either nothing, empty string, or head, or food, or tail. And if I add this class name here to my snake cell, so it will say either snake cell, or snake cell head, or snake cell food, or snake cell tail. That's how I want it to work. So I am gonna hug this snake cell string with some curly braces. They're cozy, hugging my snake cell. And then snake cell, I will append. So I will add to the end of this string my class name here. This is a variable that I created. It doesn't have to be the same as this class name, but it just was. So there is something missing. Can somebody tell me what's missing? What will this string become if class name is head? Do you see that we have snake cell and then we have class name right away, for example, head, and there will be no space in between. So it will be one CSS class called snake cell head. And that's no good. We need to have a space in between. So we just add a space. Let's add a space in front of all of these. And if it is an empty string, then empty string will be appended, and that's just fine. So, time to test this. I'm going to write npm run. Start. npm start. And here is my window. Here's the game. Welcome to Nostalgic Games. Thank you very much. Snake. And something is wrong. You guys, I hope you can help me to solve this problem. I forgot something. Oh, it says helper is not defined. Well, somewhere
on line 9, you have written helper instead of helpers.
Yeah, you see. Thank you. That was fast. Ask you guys questions more often. So you see, we have a baby snake and there is a food. Now, what I want to test is that if I refresh this window, so I reload the whole page, so I press F5 or Command R, I want my baby snake to be in the same position as it's set. We always take width divided by 2, height divided by 2. But I want my food to be randomized. I want it to appear in different positions every time we generate the game. I'm gonna refresh. You see? The food is jumping all around the grid, and it's always somewhere at a cell that's not the snake. So it's always visible and never jumps on top of the snake. Great. So we even have a state called game now. Amazing. We can change the state now if we want. And every time we change the state, what happens? I would like, if it was a class, you know, like for real, I would want to hear like a choir of voices, you know. Every time the state changes, what happens? And then you say the component re-renders. Have it as a mantra before you go to sleep. Every time snake changes, component re-renders. Okay. Say it 3 times. I'll ask you tomorrow. Every time component changes, what? It would be so cool if it rhymed or something. Maybe our English experts could, you know, make this, rephrase this so that it rhymes. We can like write a song about it. Maybe we will even put it to music and dance a hip hop song. That would be some true pink programming camp team spirit. You know what we did last summer on the C# camp? We created dances for different programming concepts. It was so cool. You know what? Like for example, for loop was this. So now we're dancing the for loop dance, okay? And we also had Boolean. Boolean is true or false. So we had like that. Like you need to decide, is it true or false? And we had, I had some crazy girls in that camp. It wasn't me who came up with that. So we also had return statement. Actually, that I came up with myself. I'm gonna show you. I need to stand up for it. That was the return statement. I don't remember what more stuff. We tried to come up with something, but then it goes a bit, that's hard. You guys, maybe you can think about it and come up with some cool dance moves for some programming concept that you, that we have learned. We've learned some stuff about promises and callbacks, and we've learned function and a function, and we've learned state and props and components and render. But yeah, how do you dance render? I don't know. Like some of these concepts are a bit hard, but I can kind of see a callback. Yeah. So that's if you want to do some silly stuff. Okay, time is 2:53. 2:53 means that we're taking a break 3 minutes ago, 4 minutes ago. So let's do that. 10 minutes break till 3:05, let's say. Hello, everybody. We should be coming back from our break. And now we're heading off to the last session of the day. My plan, I think, to give you a little mix of things. First, we will throw in a couple more functions for the snake so that you tomorrow can do some exercises. So there is, for example, functionality that might be a bit hard for you to, write yourself, and it's that the direction of the snake should change when we press buttons. So I'm gonna help you implement this now. I'm also gonna add so that the snake will refresh every half a second or 400 milliseconds or something like that. But the whole refresh logic, like where it should go and what should happen with the state, we're gonna be doing in an exercise tomorrow. That's I think, my plan. I'm gonna, right now, I think in the guide, exercise says just implement the tick function. This is the tick function that I'm talking about. Tick like the clock, Every time the clock ticks, our game state changes. But I haven't given you yet any help with that. So I'm gonna change a bit in my guide so that I add some help in that exercise, and you will do that tomorrow. Okay, so changing the direction of the snake. So we are not talking about changes to the, I'm sharing the screen, right? Changing to the state of the game. We are not changing the state right now. You can even see it from Visual Studio. We have this set game function and it's grayed out, meaning that we're not using it. It means that we don't ever change the state. So our game right now is completely static. There is no way to interact with it. Yeah, we have refreshed it a couple of times and have seen that the food appears in different places, but this is not really an interaction with our component. We're just re-rendering it every time. So now I'm gonna add a change to the state so that the direction of the snake will change depending on what button I press. The direction of the snake is this thing, deer. Right now it's right, but it will change when I press the 4 different buttons. So how do I do that is the question. So remember, was it Prey that asked me about what different things do I need to clean up when creating use effect? One thing I need to clean up is a timeout or an interval, set interval. We did clear interval. Now I'm gonna create a listener for the key down event. And this is the standard DOM API functionality, something that's built into like the standard JavaScript plus HTML functionality. So we go to index.js of our snake. And under the state creation, under const game set game, we're gonna add an effect. So now we have some code later that generates the cells. And I think that's okay. It generates the HTML here. And there is some logic for that. So just below the state creation, we're gonna do use effect. In order to use this function, we need to import it along with use state. So comma, use effect. And we are gonna call it. Again, it takes 2 parameters. what effect it is, like the function that should run, and the dependency array. So we're gonna create this function, and we are gonna decide what the dependency array should be. So let's think about it. We are gonna add a key down listener, meaning that whenever somebody presses a key, some callback function will fire up and see what key was pressed and then change the snake's direction. So that's what we're gonna add inside here. And adding this listener needs to only be done when the component is rendered for the first time. We don't need to do it on every render. And it doesn't depend on any state variables or any variables really. We should just do this once when we render our component the first time. And when we leave the component, this listener should disappear. So when we go to another game, for example, memory, pressing up, down, left, and right shouldn't do anything. So this listener should be removed. So, question, what dependency array should we send? We want this to only render once, to only happen once when the component renders. And I told you about different cases.
Is it generate game?
Generate game is a helper function we wrote in the previous state, right? I'm asking about this use effect function. It should take a dependency array. What are the different options? We described it in the comment before. This is the comment that I wrote for you guys yesterday. Use effect takes a dependency array. There are three different options here. Undefined, meaning effect will be run every render. Empty array, hint, 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 hint. The effect will be run on only on the first render, that's it.
Yeah.
And then some values here. The effect will run anytime any of the values change. So this is our answer, empty array. And now we are going to add that listener. And now comes some code that is probably easily Googleable. I'm gonna write it for hand. Window, this is an object available to you always when you do web development. Window.add event listener. And then we first here say, what event do we want to listen to? And there are different types of events. We can say key down. There is key down, key press. Key down is actually the event of pressing it down, and it fires right away. Key press is an event that fires after we have pressed it. I don't know, I really didn't think much about that decision. Key down worked for me very well. Key down is the event, it's a string. And then here we will pass a function that will fire when a key is pressed. And this function will take an event object, which will have a key code. So how should we do this, I wonder? Maybe we can extract something into our helpers class so that we don't create another big function here. This is a little bit hard. But give me 5 seconds and I'll think about it. I'm gonna write it the way it is and I'm gonna put it here for now and not take any more time. Maybe I'll refactor it later. So I'm gonna call this function handle key press. Just like that, without any brackets, without any parentheses after, I am referencing a function that I haven't defined yet. The definition comes here, function, handle key press, and it takes an event object. And then it will do something with it. Now back to our use effect. We said we create a listener, and then we want to do what? We want to clean up after ourselves. So we're going to return a function for cleanup, for cleaning this mess up. So we do return parentheses, and then there we go and say window, remove event listener. So there is add event listener, and then there is a remove event listener. And we send what event we want to remove it for, key down, and then we say what listener we want to remove for this event. Maybe we have many listeners for key down then. And it's actually possible to just say handle key press. This is what I'm removing. Again, this was a bit confusing for me, that I can just send a reference to this function again, but that's what internet tells me to do. So we're done with the use effect call. Now we're gonna implement handle key press. And so inside the event code, there is something called key code. Different keys on our keyboard have codes. Like for example, how do we know that the up button has been pressed? Well, it has a specific code. And I found a nice page to look up what codes correspond to what buttons, and it's called keycode.info. Here, it's very in your face, keycode.info. So what I do is I come to this page and it tells me press a button. So I press up button, for example, and it tells me, oh, that's arrow up 38, down is 40, left is 37, right is 39, and all the letters also have codes. So W has 87. Just test, press any button on your keyboard and you will get the key code. These are the codes that we are gonna process. I have linked to this in the guide as well. If you refresh it though, it's under the snippet that we're writing now, if you're following the guide. So, we are gonna now compute the new direction for our snake. So I'm gonna create a variable for it that I'm gonna set to different values depending on what keys I press. So I'm gonna write let new deer, and then I'm just not gonna set it to anything. It's undefined right now. And then, have you ever seen a switch statement? You know what that is? Yeah, some people have, some people haven't. So a switch statement is handy if you are about to write something like, if this, do this, else if this, do that, else if that, do that. But the thing about it is, if it takes one value and it compares this value to different values. So it has cases. It takes a variable and then it says, case 37, I want to do this. So if the value of the variable is 37. So I'm gonna show you. We write switch. And then in here we write event. It's the variable I receive here, which is passed to me from the DOM API. When somebody presses a button, since I added a listener, this is my listener, handle key press. It's gonna handle a pressed key and it's gonna receive an event as the parameter. And then I go and say switch on event dot key code. And then I'm gonna write different cases. So there are 4 cases, up, down, left, and right. But also we have WASD. I wanna add those two. So, and then the syntax goes like this. For every case you write case and then value for this case. For example, let's go and check what the left key is, for example. Left is 37. Great. So I'm writing case 37, colon, and then I'm writing what I want to happen. Normally there is a line break here. I want new deer to become left. And then important, something that people, including me, always forget is that the switch statement, inside their cases, there should be a break. Otherwise, it's gonna work in funny ways. So we're gonna insert a break here after. And then we can just copy this code and change the values. So we're gonna have 4 cases for left, up, right, down. So I'm gonna copy, paste this. It's nice when I save, everything gets pretty. That's if you have prettier and format on save Visual Studio code. So new direction is going to be to left, then up, then right, then down. And I'm going to go check what those keys are. So up is 38. Right is 39, down is 40. Oh, that's very handy. 37, 8, 9, 40. 37, 38, 39, and 40. I can also add the cases for my other 4 buttons. And if I wanna say that for multiple cases, this should happen, then I just add another case, something here. So let's see, left is A, the key A, and it is 65. So case 65. So you can actually list more cases like that. Maybe you have not seen this, but maybe you have seen weird behavior when you forgot a break, and that weird behavior is called fall through, meaning that we do first what the first case says, and if there is no break, we'll fall through to the next case. So we'll fall through from 37 to 65. So for both of these cases, left is what we want. And I'm just gonna go faster. So up is case 87. Right is case 68. Write colon after every case and number. If you don't want to type this by hand, copy this from the guide. Function handle key press. This is what we're writing. This part down here, set game, I'm gonna explain later after we've done this. And I'm gonna type that by hand. So case 40 and 83 are the same. There. Now I have a new direction. It's either left, up, right, or down. Or if I haven't listed a key that's not here, if I haven't listed a key here that I have pressed, say that I have pressed space bar. What's our new deer gonna be at this point here? It's gonna be undefined. We have not defined it. It's gonna be undefined. And if we press any other key, we should not do anything. So remember that. Now we have our new direction and we want to update the direction of our snake. And the snake is where it's in our game. Yes. And what do we do in order to update the state? We have a function for it. It's this one, set game. So we can just write game.snake.deer equals something. We need to use this function for get this to work. To get this to work. So after handle key press, we can either write if new deer is defined, if new deer, and then set game. Maybe it's easier actually than what I have here in the guide. So I'm gonna write like that. If new deer, if this value is defined, I can write equals undefined. It's the same thing if just writing like that. You can put anything in this if statement. JavaScript is quite unique with that, I think. Well, for some other languages also, but in Java, this would be like, huh? This is not a Boolean. What are you trying to do to me? Only take Booleans here. JavaScript is like, everybody's welcome. Strings, arrays, object, what have you. Remember empty string and empty array from the evaluation? From the Mentimeter. Empty string is false, but empty array is true. That's a brain fuck for me, but I can find some logic in it, I think. Anyway, JavaScript. So if new deer, then we want to set game and we want to take a previous version of the game and just change one little bit. So the state of the game depends on the previous version of the game. We only want to change one little piece in it. It's the direction of the snake. So we write old game is the previous game object, and we want to create a new version of it where everything is copied except for snake. Well, food is everything except for snake. But anyway, it's good practice to, like, if you only are replacing one thing, write ... old game. So we copy old game, but, all right. So when I use arrow functions, I cannot return an object in a simple way like this. If I'm using curly braces, it interprets this as the scope of the function and not an object. This means that this is what I'm doing. So return and then object. So we have ... old game, and then we want to copy old game but replace snake. And what should the snake be? Well, it should be, again, copy the previous snake but replace direction. So again, we open curly braces, ... and now where is my old snake? It's in old game dot snake. So now I have copied the old snake, but I want to replace the direction. So now then I just write deer is what? What we have been working on all this time. New deer. There.
Can I ask something?
Mm-hmm.
I think I've missed something, but what does the line 36 mean? If new deer?
It means
It isn't
new
a bool,
deer
is it?
Yeah, exactly. So new deer is a string, right?
Yeah.
If we
Oh, you mean if it's not undefined?
if it's, yeah, exactly. If it is defined, we could say.
Yeah, because for me it looks like you're asking a bool, like if it's
Yeah.
true or not.
Yeah. So
Okay.
we can say if new deer is not undefined,
Okay.
or we can say if new deer. Think of it as like there is something in that variable.
Okay. Thank
So it's not nothing, it's something there. Yeah. So now we go and say set game. When we press a key and we do that, this listener will be added when the component is first rendered. Let us test this using React DevTools. I'm gonna go and run npm start. And I'm gonna open components tab. I'm gonna go to my snake game. And I'm gonna go and find my snake component. It's somewhere down below in this big tree here. So this is the state of the game. This is my snake. It has direction right. And let me now press a button up. It changes to up. I press left, changes, right, changes, down. I'm gonna test my WASD also. WASD. It works. The state is changed. The direction of the snake is changed. And now for the last bit, before you guys implement the core functionality of this game. And the plan that you'll do that tomorrow. I also want to show you tomorrow the model, the pop-up functionality. I think this is where we will round up the camp. And remember we said that React components should be reusable. And we have created a status bar. It is reusable. You can put it in the snake as well. Just import it and render it at the top here of your game container. And then it's possible to implement so that it shows the score of the game. How many, what's the length of the snake's tail? Because that's how much it has eaten. Well, -1. It starts with a little tail of 1. That's the score of the game. That could be shown in the status bar. Quite easily, you just say that status bar, your status is, and then you take out snake's tail length from the game object. Game.snake.tail.length -1. That's the score. You can do it if you feel like it, maybe in your own time. So last bit is that we add an effect here. What I want is for my game to refresh every second. Or sorry, we are going to choose some faster pace here because otherwise it's a bit boring. My pace that I like is 400 milliseconds. So underneath this use effect, or actually let's do it above it here, because this use effect is friends with this handle key press and I don't want to separate them. So right after use state, I'm gonna use effect, and it takes a function that will do something. And yeah, so what will this function do? This function, sorry, moving my windows around a bit. I want my game state to update every half a second. It's kind of similar to the timer that we implemented. There we wanted elapsed time to be updated every second. Remember? Okay, and this is something that I will only do when the game first renders. I'm gonna start the timer right away and send the snake off to its adventures. Right when you enter the component, when it renders, the snake should start moving. And I'm gonna create this interval. This is what I'm gonna do. Only the first time component renders. So what is the dependency array here? I'm gonna do something once when the component renders for the first time, and that's it. So it can be undefined, which means I send nothing. That means that we do something every time component renders. And then the second case is empty array. That means once when the component renders for the first time. So I'm sending empty array here. And now I'm gonna create an interval. I'm gonna say I want my game state to update every half a second. So let me just do a little test, and I'm gonna just do a console log. I want something to be logged to console every half a second. How do we write that? I think you might be tired, so I'm gonna give you that as a task. So set interval. It takes a function as a parameter. The function is just gonna do console.log. Let's log whatever, math.random, something that we learned today. And it's gonna do that every what number milliseconds? I'm gonna choose 400 because I like it. There. And one thing that the use effect should do if we're creating an interval, what should we do? We create something.
Enough.
Clean it up, exactly. So this function here should return a cleanup function, which we write like this, clear interval. And what does clear interval want? Interval ID. Interval ID is something that we can fetch from set interval. Right now, we are not saving the return value that it gives us. It actually gives us a return value. So we can write const interval ID. That's what it returns. And that's what we will send to clear interval. That's it. Let's see if this works. And do you see this? Random numbers are being printed to my console. And this is how fast I want my snake to move. Do you think that's too fast? Change this to a bigger number. Change 400 to 500. But it's easily changeable, and you will see when you play what's a good value there. So we're not going to be doing a console log, right? We are going to be updating the game state. So in my guide, I called this function tick. Quite common name for a function that calculates something on every tick of the clock, so to say. So let's do that. And the way this function is going to work is it's going to take a game object and it's going to return a new game object. Depending on the previous state, it's going to return a new state. If the snake is in the middle looking to the right, and the food is wherever it is, not close to the snake, the next state should be that the snake has moved. one step to the right. And the tricky bit there is how you do with the tail, because, you know, it goes like that. What you can do is you can remove the last cell of the tail and add the first cell to the tail. That's how you make the tail move. So that we'll do tomorrow. We will implement a tick function that will go here. Instead of console log, we will be calling the tick function. Let me already place it. So I am instead here gonna go and say set game, because that's what I'm gonna be doing. And here I'm gonna send helpers dot tick. And this is nothing that exists, but I want this to be a function. So I go to my helpers and define here at the bottom function, export function tick. It takes a game object and then it will do lots of things to it. It will look at it from different angles and it will create a new game object. But now for nothing to crash, I'm just gonna go and return the same object. So I'm not doing any changes to it. So now I have defined this function. And now my index.js finds it. Should at least, please. All right. You know how if we can do a little test just to see visually that it works. Kind of funny one. I want, when I tick, want my food to show up in random new places. It's very easy to fix. So helpers return. We copy the game. .. game. But food is gonna be generate food. Nice, right? This is gonna create a whole new position for our food. And I'm doing it just for fun. You will rewrite this. So, no. What happened? So now it should update the game state with this. Snake and food, it should keep the snake. Food is generate food, and I made some mistake somewhere. And you guys should take a break. So this is finished, and that was just me having fun. I am gonna upload this to GitHub any minute now when I fix my problem. We should go and chill. In 10 minutes, we are meeting Access in the Zoom call. Is it a separate Zoom call? It's a different Zoom call, so it's not here. So we're gonna close this one, and you go to How space. On day 4. Q&A with Access. So after the